Okay, now let's do some questions. So we have a magnetic field from left to the right, and there's coil of wires and making an area. Okay. The question asks me now, the flux is this much. Okay. Remember the symbol for magnetic flux, and yep, magnetic field is this much. What is the area of this loop? Okay. So use the equation and put it down the numbers. I think there was yeah, I think there is a hmm, yeah, I think this was a typing mistake in the question. And if you do the math, say, okay, the magnetic field equals to 2 times 10 power of minus 2 Tesla. Okay, so put it in your equation, you have 4 times 10 power of minus 4 meter square. So, yep, that's the area. Now let's look at this question. So again, okay, we have this situation. The question asks me, what is the magnetic flux between the poles pieces? So basically, what's the magnetic force between the north pole and the south pole? Okay. So remember, flux related to area. So write down the equation. So yep, magnetic field is this, and the area. Remember, if you're using this equation, your area must the in the unit of meter square. Okay, so you need to times 10 centimeters, which is 0.01 meters, times 0.04 meters. Okay, convert all the values to meters. Then put in your calculator, you get an answer. The unit is Weber, WB. Okay, have a look at this question. Okay. We have a solenoid, and let's use our right hand rule. So if you use the right hand rule, remember your finger is always the current. Sorry, your thumb is the current, your finger is the magnetic field. Try to grab the outside lines. Try to grab this one, because it's outside. Okay. So you say inside that circle. Okay. So if I if I cut it in half, I draw a cross-section area. Okay. So the current on the outside, okay, say if this is the outside, goes up. Use your right hand grab rule. In the circle, the magnetic field goes into the page. Okay, goes into the page. So turn it around. So the magnetic field goes from the right to the left. Okay. So just let me write it down. Yep. Okay, inside. Okay. So yeah, and have a look. Okay, we need to find the magnetic flux and of this area. Now, if you look at it, the area lies parallel to to the magnetic field, to the direction of magnetic field. So in this case, okay, the magnetic flux will be 0 Weber, okay, because okay, the area has to be perpendicular to the direction of magnetic field. Now again, look at this question. So what we have here is we have a magnetic field from north to south, and I need to find the magnetic flux at the position figure 3C, okay, here. So magnetic field goes from north to south, and 3C. So in this case, the magnetic field interacts perpendicular with the area, so magnetic flux will be B times A, and putting down the numbers. Okay. So magnetic force in Tesla, and we need to find the area. Okay. 5 centimeters square. Remember, we need to change it to meters square. So what we have is, now if you're really confused, like me, I'm confused how to change centimeter square to meter square. Let's do this. Okay. 5 centimeters times 1 centimeter gives me 5 centimeters square. Okay. So 5 centimeters is 0.05 meters, and 1 centimeter is 0.001 meters. Just type them in like this, and you get an answer in the unit of Web. Done. Okay. Yep.